How to Create a Glitch Monologues Season 25 Chapter 2. This is Season 25 of How to Create a Glitch in the Matrix Monologues Episode 2. In this episode, we will be talking about how to calculate the task time or period of a cycle using data from a previous oscillation. In the last episode, we introduced an equation to calculate the ratio of the time it takes to complete a task involving the completion of a bodily rhythm over the period of that rhythm. The idea was that when your consensuality is stable, the ratio is equal to E times 10 to the exponent negative x, where x is equal to the level of the cycle of bodily rhythm. In this episode, we will be introducing a new equation that reflects the two components of the actual rhythms and their corresponding task times. It appears that for any bodily rhythm, the time it takes to complete the task divided by the period is equal to the time it took to complete the task the previous cycle, divided by the period of that previous cycle, plus E times 10 to the exponent negative x. The reasoning is as follows. In every cycle, there are two components, the non-consensual oscillation and the consensual oscillation. Since we know the consensual oscillation is defined by E times 10 to the negative x, where x is equal to the power of the given bodily cycle, we know that the non-consensual component is equal to the last cycle. This is because consensuality in the past involutes into non-consensuality in the present. This means that the non-consensual component of each cycle is equal to the ratio of the time it took to complete the task involving completion of that cycle over the period of that cycle. The ratio of the time to complete the task relative to the cycle period is equal to the ratio of the previous cycle plus E times 10 to the negative x. That is to say, if E times 10 to the negative x is equal to our stable consensuality, then it follows that subsequent cycles will reflect that same consensuality at the same ratio. The explanation for all this is the following. Your bodily rhythms are conditioned to reflect E times 10 to the exponent negative x according to synchronization. When synchronized, any change is reflective of a variation of E times 10 to the negative x. In other words, when your consensuality is stable, changes in your bodily rhythms are quantized by the unit of E times 10 to the negative x. However, this does not mean that the equation will always be accurate, as perturbations caused by other cycles can impact its accuracy. So in other words, the ratio of the most recent cycle is equal to a non-consensual plus a consensual component. We know the consensual component because we have established that it is equal to E times 10 to the negative x. We know the non-consensual component because it is equal to the ratio of the last cycle, or task time over period time. In the balance, to the extent that our cycles are uninterrupted by other actions, this will be the equation which defines the most recent cycle. That's the end of the podcast for today. If you enjoyed it, please like, comment and subscribe.